the first thing was to do is condense. So I draw this, and that. When I condense, I don't draw it as nicely because it's like I just want to get it done. You know, it's a tool. So then this one becomes 9 microfarads. This becomes 4. Well, it doesn't become, it still is. And that's 3 volts. And then now I got to do it again. And this time we have 1 over 4.5 plus 1 over 9. So that becomes 2 over 9 plus 1 over 9 becomes 3 over 9. Flip that, and you get this. 3 microfarads, 3 volts. So what is the total charge on this system? So Q is CV. So the total charge on this system is 9 microcoulombs. Don't forget the micro, that's kind of important. Just a little bit. You will only be off by 6 orders of magnitude if you forget it. Okay, so now we say that means, okay, how many coulombs of charge is connected to the battery? How many coulombs of charge is connected to the battery? Aaron. Sorry? Oh, okay. This is micro. So technically, if you wanted to give me that answer, you'd have to give me 0.000009, right? Because it's 9 times 10 to the minus 6. So yes, but Aaron did what I wanted him to, which is he identified that this is the amount of charge connected directly to the battery. So do we see here, right there, right now, how much positive charge is on this capacitor, Andrew? Oh, Andrew's not here. Whoops. Did I mark him absent? I better check that. Tiffany Chan. How many coulombs of positive charge are on that capacitor? This one right here. While you do that, I'm going to go mark Andrew absent. Oh, I did. Yeah, I did. And I did. That's why it looks like that. Okay, 9 what? 9 microcoulombs. So this is going to be 9 microcoulombs of charge on that positive side. Okay, now, how many coulombs of negative charge are on the other side, Jenny? Of that exact capacitor? If there's 9 microcoulombs of charge, positive charge on this, how many coulombs of negative charge are on the other side? Exactly the same. Does everyone realize that? Okay. Now, there must be 9 to the battery on this side. This one's an easy one, right? Because look, these add up to be 9. How easy is that? Because what we're doing is we're saying proportionately. This one is bigger, so it should have more. This one is smaller, so it should have less. And then you just do the proportion, right? Add them together, and this will be 5/9 of the total amount of charge. This will be 4/9 of the total charge. Since the total charge is 9 microcoulombs, that makes this 5 microcoulombs, and that makes this 4 microcoulombs. And then now they said, come up with, wait, yeah, that's charge. They said voltage. So we just take that equation and say V is Q over C. So that makes it super duper easy for this. Each one of these is 1 volt. And that should make sense. Why does that make sense, Vivian Wynn? That both of those would have the same voltage. Oh, thank you so much for answering that question perfectly. Because they're parallel, right? They have the same voltage drop across both. All right. So then that means this one must be 2 volts. I don't even have to do any calculations. Because if there's 3 volts coming out of the battery, then 1 volt each on these parallels, that's got to be 2. And it should, you see it works, right? is 9 microcoulombs, 4.5 microfarads. That's 2. We're good. And that, ladies and gentlemen, is that problem. Questions? No, of course not. All right, we'll move on to the next problem.